Hello, today we're gonna learn redox reaction. Redox stands for reduction and oxidation. We can determine a substance is oxidized or reduced only after a reaction happens. So how to identify whether a substance has been oxidized or reduced? There are four ways to determine whether a substance has been oxidized or reduced based on gain or loss of oxygen, gain or loss of hydrogen, electron transfer, and change in oxidation number. So now let's focus on the first one, gain or loss of oxygen. In this reaction, after reaction, magnesium gains oxygen, while oxygen molecule lose oxygen. Therefore, in terms of gain or loss of oxygen, magnesium is oxidized, while oxygen is reduced. Next one, gain or loss of hydrogen. In this reaction, after reaction, Cl2 gains hydrogen, while H2S lose hydrogen. Therefore, in terms of gain or loss of hydrogen, H2S is oxidized while Cl2 is reduced. But how if there are no oxygen or hydrogen in a reaction like shown in the reaction below? Thus, it's time to see redox reaction in terms of electron transfer and change in oxidation number. For now, let's focus on the electron transfer. Please keep in your mind that electron transfer only happens in ionic compound. Let's take a look on this full reaction. Zinc atom became zinc 2 plus ion, meaning that zinc atom has lost 2 electrons. In the other hand, copper 2 plus ion become copper atom, meaning that copper 2 plus ion has gained 2 electrons. These two equations at the bottom one are called half equation. The numbers of electrons lost and gained in a redox reaction must be equal. You may memorize this mnemonic: Ulrich, oxidation is loss of electron, reduction is gain of electron, in order to remember the oxidation or reduction. Thus, zinc has been oxidized while copper 2 plus has been reduced. The last one, we can extend the definition of redox reaction in covalent compounds. We do this by using change in oxidation numbers. How to deduce the oxidation number of an atom or element? Here are some rules to deduce oxidation number of an atom easily. Rule number 1. The oxidation number of uncombined element is 0. For example, oxidation number of hydrogen molecule is 0, as a molecule is also 0. Rule number 2. In compounds, these atoms or ions have fixed oxidation number. Elements in group 1 are always positive 1. Elements in group 2 are always positive 2. Oxidation number of fluorine is always negative 1. Oxidation of hydrogen is positive 1, except in metal hydride, for example sodium hydride. The oxidation number of hydrogen is negative 1. Oxidation number of oxygen is negative 2, except in peroxide, H2O2 it is negative 1, and in F2O it is positive 2. Rule number 3. Oxidation number in monoatomic ion is always the same as the charge. As you can see, the charge of copper ion is 2 plus, so the oxidation number of copper is 2 plus. Silver is plus 1. Chloride ion is negative 1, and sulfide ion is negative 2. Rule number 4. The sum of oxidation number in a compound is 0. Here we have KMnO4 compound. This compound has total oxidation number of 0. Rule number 5. The sum of oxidation number in a polyatomic ion is the same as the charge on the ion. Here we still have KMnO4. KMnO4 consists of K plus ion and MnO4 minus polyatomic ion. Oxidation number of potassium is positive 1 because charge of potassium is positive 1. The polyatomic anion consists of 1 manganese and 4 oxygen. Therefore, the total oxidation number of 1 manganese and 4 oxygen is equals to negative 1. You just need to input negative 2 as oxidation number of oxygen, then you can know how much is oxidation number of manganese. Rule number 6. The more electronegative element is given the negative oxidation number. In molecule ICl3, Cl atom is more electronegative atom. So Cl has oxidation number of negative 1 as Cl is from group 17. Hence, the oxidation number of iodine in ICl3 molecule is positive 3, even though iodine is also from group 17. So let's take a look on the full reaction, redox reaction. Before you determine which substance has oxidized or reduced, you have to deduce the oxidation number of each atom in the reaction given. Oxidation number of I is negative 1 as the charge of I ion is negative 1. Bromine is an element, therefore its oxidation number is 0. As in bromine, iodine also has oxidation number of 0. Bromide ion has oxidation number of negative 1. By seeing the oxidation number of each substance before and after reaction, we can conclude that oxidation number of I- was increasing. Therefore, I- has oxidized, whereas bromine decreased in oxidation number, meaning bromine has been reduced. That's it. Got it? Now it's time to practice